Hello everybody and welcome to this video on Bohr diagrams. I'm going to show you how to draw Bohr diagrams today. So here I'm looking at my periodic table. One of the ways that we can represent what an atom of an element looks like is by a Bohr diagram. So you probably learned these in Science 9. They look like this here, where you have the electron shells drawn as circles around the nucleus. We usually just put the symbol for the element in the middle there to show you what it is. So I'm going to review the rules first, and then we will practice drawing some. So when you draw a Bohr diagram, these are the electron shells where the electrons spend their time around the nucleus of an atom. So when we draw it, it's important to remember the first shell can only hold 2 electrons. The second shell can hold 8 electrons, and the third shell can also hold 8 electrons. When you get to Chem 11, you'll start drawing different kinds of diagrams that go above the 3 shells, but we are only going to learn how to draw up to calcium in Science 10. All these transition metals get a little bit complicated, so we're going to stop at number 20. So you won't need You'll be able to draw 4 shells, but you won't fill the 4th shell up. So all you have to know for this year is 2, 8, and 8. The only other rule is you have to place the electrons by themselves first, and then you pair them up after. So I'm going to show you what that looks like. So let's draw an atom of nitrogen. So here's nitrogen. It's number 7. Remember from the reading that you just did that the number 7 means the number of protons, and in an atom, a neutral atom, you'll also have 7 electrons. So let's draw that. So I'm going to draw an N on my paper, and I'm going to draw a shell. So N has 7 electrons, so I'm going to first draw 2 electrons in the first shell. That means that there are 5 in the second shell. So here we go. 1, 2, 3, 4, 5. There we go. That's a Bohr diagram of a nitrogen atom. Now you'll notice that I drew them. So 1, 2, 3, 4 alone. That's our rule. Then I paired that last one up. I also went clockwise, starting at, if this was a clock, starting at 12 o'clock, and then went clockwise around. That is convention. That's how your chemistry teachers would like you to do it. So start at the top, 1, 2, 3, 4. Okay, let's try another one. Let's try a metal this time. Let's do sodium, Na. So you start by drawing the symbol and a shell, and now I know I have, this is an atom, it's neutral, so it has 11 protons and 11 electrons. So 1, 2, need another shell. It's okay if they're not 100% circular. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's full. So now I need to draw a third shell. 11. Okay. This outside shell is called the valence shell. And any electrons in the valence shell are called valence electrons. And this is important when we start talking about ions, which we're going to do right now. So when atoms form ions, remember an ion is a charged particle. So it's when an atom has lost or gained electrons. And the reason that atoms gain or lose electrons is to become more stable. The most stable arrangement of electrons is to have a full outside shell. So here you can see that we would need 1, 2, 3 more on nitrogen to give it a full outer shell. On fluorine, we would need 1 more. In sodium, what we would actually do is lose an electron to get a full outer shell. Metals, the ones on this side of the staircase on your periodic table, metals will donate or lose electrons. Non-metals will want to gain electrons to get a full outside shell. So if I was going to draw a nitrogen ion, there's a couple ways I could do it. I could draw the atom first and then say, okay, it needs 3 more electrons to give it a full outside shell. So I'm going to draw 1, 2, 3 electrons. And then to show that it's an ion, that it's gained electrons, you put it in square brackets, and then you have to give it a charge. So it gained 3 electrons, and electrons are negative, so its charge is -3. Okay, that's one way you could do it. You could also look at your periodic table and say, oh, 3 negative means 3 more negative electrons. So I know instead of drawing 7, I'm going to draw 7 plus 3, 10. What about for a metal though? So here we have sodium. So again, you could draw this and then say, oh, I see it's just going to lose this electron. Or you could look at it on the periodic table and say, okay, sodium would have 11 electrons, but when it makes an ion, it gets a plus charge, so it is going to lose an electron. Remember, electrons are negative, so a positive charge means you've lost one. So that means that I'm just going to draw, instead of 11, I'm going to draw 10. So I will do it underneath to make it look neat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget about this square bracket. And now my charge is +1. You can write +1, or you can just write a positive. Scientists are very busy people and don't like to draw that 1 in there, but you can if that helps you. I'm okay with you doing either one. Okay, so that's how to draw a Bohr diagram of an atom and an ion. I'm going to get you now to do some practice. So first of all, try beryllium as an atom and as an ion. Do beryllium, atom, ion. Do lithium, atom, ion. Do oxygen, atom, ion. And do hydrogen as an atom and an ion. So what I'm going to get you to do now is pause the video, and then come back when you're ready to see the answers. Welcome back. I hope that you managed to do those practice questions okay. If not, you're welcome to come find me and get a little extra help, but here are the answers. So an atom of beryllium has 4 electrons, so 2 in the inner shell, 2 alone in the outside shell, and then you lose those 2 to become beryllium 2 plus or plus 2. It doesn't matter which order you write the plus and the 2 in. Your periodic table has it with the number first. Lithium has 3 electrons and an atom, but only 2 in an ion, so it becomes +1. And I wanted to show you this one to show you that if you have an ion, you're either going to have it looking like this with a full inner shell of 2 or a full outer shell of 8. So it's really important to put the element symbol in the middle because that's how you tell them apart. They have the same number of electrons because they're all looking to get that full shell. So here's an atom of oxygen and an ion of oxygen. So you can see it has 2 empty spots here. It gains 2 electrons. You can also tell that by looking at its charge on the periodic table. Now the last one was tricky. If you got tripped up by this one, that's totally okay. I did it on purpose. Hydrogen, as you can see, only has 1 electron when it's an atom. So it can either gain 1 and become a negative hydrogen ion, like you see up here, or it can lose that sole electron and become a positive ion, like you see up in the left-hand corner. So hydrogen can become two different ions, a hydrogen minus or a hydrogen plus. And we're going to mostly see this one, especially when we get into acids and bases, but just so you know, it can act both as a cation and an anion. I hope that was helpful. Go ahead and do the practice questions now.